Okay, let me just get this camera from moving. Here we go. All right, so sorry it's been a little while since the last bit of projects. My computer went down and I could not get a PC that could properly run the softwares that I use um, until this week. So this is going to be a number of different things. First, talking about one of the first things that I was working on the Slingshot forums was a spin shooter slingshot. This was the very first model, version 1. I've gone through a number of versions since. This was version 4, and I realized that the printer that I use, maybe you could see this, really, because of the 0.8 millimeter nozzle, it's very difficult to get the high resolutions that's really needed for that thin a wall. And so I skipped out on that and ended up making this design, which came out perfectly. This one was actually did very well. And so I was very, very happy with that. But one thing I realized when I made these longer slots is that it allows the bands to slide farther towards the middle, which meant the bands would more often than not fall off into this section instead of staying on top of the forks. So I did a couple of redesigns, but the other thing I found is that this ridge didn't need to be smoothed out at all. The bands never touch it. They stay nicely in this groove. This is the last version I finally came up with that's already to go. And what's cool about this is it's actually that little slot that I just created, it keeps it perfectly positioned facing straight out to the middle there. That's really, really cool how that worked. And this is 10 millimeters thick, which you can see the difference between that and this one here. But the inside diameter here is 7 millimeters. So the bearing will still fit right in there and be flush to this flat part right there. So that's pretty good. I'm really, really happy with that. In fact, it did printed so nicely. This is actually quite smooth. I might not even have to use the lacquer or anything like that on it, which would be great. That would definitely save some processing time. And it didn't take that long to print, only about an hour. So that's really, really nice. Now, I was working on the design for a like the earbud style, collapsing slingshot, where you have all the components wrapped up into it. It looks just like this, but this was way too small. This was the design I actually showed on Onshape, and it was just way too small. Nothing could fit in here. It wasn't very useful. So I redesigned it so that you could lay it flat. And then since doing this one, I realized that I wanted to at least make it wide enough so that you could lay one of these perfectly flat inside of it. So the next design comes down a little longer and allows it so when you wrap the bands, it lays flat. So that solved the problem for this piece. Now for this piece, I did make some thicker sides so that it would be a little stronger, and it's plenty strong. The problem is the way I had to print it was like the way it is on my hand, which every layer going this way, and it creates some issues with the holes in the resolution that I'm printing. So, plus I find that because of how wide it is, it's actually not that comfortable to hold. So I'm actually going to start from scratch on this and maybe design something completely separate. Originally, I wanted to design like like something that looked like an earbud holder but could be used as a slingshot. But what I'm realizing is I really just need to make a really well designed folding slingshot. So keeping it really, really small like this, but folding it out into a large slingshot. Somebody just posted a design online. It's very similar to kind of what I'm gonna probably end up as. But the difference between that one and this next one, is that the forks in that design were inside the handle, which made the handle very, very large. My design is going to make it so that the geometry of each arm encapsulates, because this is the inside where the palm swell would be folded into. I can make this shape such that it will actually fit the palm swell when it's closed, and then when it's opened, you'll see you'll be able to hold your grip and have that nice little palm swell. So it'll be still very, very short, but end up being quite long when all is said and done. Just like a lot of the slingshots that I see. Now, I'm not exactly sure about the dimensions on those ones I've seen on the forums, but I think that's going to work better for that purpose. That means I can make this piece solid instead, and I can make it all really nice and smooth instead of having to refinish it. And I can start using other types of band attachments. I can literally make that top component any combination, whether it's for small tubes like these or flat bands, you know, anything like that. So that's the slingshots. I'm still working on the design for the modular hand grip system. I'm going back to an L-shaped bracket, but the difference is that I'm changing the orientation of the locations for all of these holes and this L piece entirely. It's going to be shifted forward so that the back end lines up so the curve continues, and this becomes more of the space in front is going to be used. The concept behind this handle, forget the slingshot for a minute. The handle is good. I want it to be useful as the top end of a walking stick. Have it so that this can be used as a gun rest. In fact, I don't see why one of these little slingshot heads couldn't be made to be used as a gun rest. And I'd also like to make sure that it fits properly on a variety of longer poles to make it work well as a walking stick. And then these two holes here allows for a wrist brace, but if I shift these holes forward instead, they could allow for a combination of reels and all other types of attachments that could be useful in that regard, to kind of let somebody design whatever they want to also be attached down at the bottom as well as at the top, to provide as many orientations that somebody can use, as many flat edges and clear, you know, diameter holes that are easy to make. So I'm going to continue to work on that. I'm probably going to not use this large diameter. I'm probably going to use something a lot smaller to keep it strong, but also make the nuts and so on smaller. And I think that would be quite useful. I could probably just go with the 1/4 inch, and that would probably end up being just fine. We'll have to see. All right, other projects. One thing that I was in the car on a long car ride with my wife, and she came up with this brilliant idea. Now, I've seen similar things done with knife sheaths, but I've not seen one that looked particularly sleek or had the ability to be changed on the fly depending on your purpose. So one of the things I'll be working on over the next month or so is a knife sheath. I'm going to use the K-bar as my template, but it's going to work kind of like the way beads work on a necklace, where the scabbard that holds the knife slides into a sections of components that can all be taken off, slid on, and each one of those can have its own function. One could be for survival, one could be for military style usage. You have specific components for whatever you're doing. So if you're out in the woods and you want to do slingshot related stuff, you could have a component on there that would convert the handle itself into a slingshot, or the bottom end of one, something like that. Or we could have a component that slides on. The idea is for at least 2 components to slide on together at the same time onto the scabbard. So you could have multiple components. And 3D printing is perfect for that application because it lets you do geometries that are pretty much impossible with injection molding. That's one project. The other thing which I was surprised about. My wife was looking for makeup brushes, and I was thinking, why did they not, like, there's these huge kits that they have want people to carry with like 20 different brushes. Well, why not you design it like a ratchet set or one of these, right? I mean, this has one handle and it has infinite little heads. Now, obviously, brushes are much, much thicker and would require a different style case and so on and so forth, and you wouldn't obviously be able to carry this many. But imagine if there was one, two, three, four, five, six brushes that people would use for makeup, and you can adjust them as you want, and then you have a handle that goes with it. I think I decided that you don't want any mechanical functions to lock it in. You'd rather it be simply a magnet, which is not dissimilar from this. It uses a hex style mechanism and with a magnet on the bottom to hold the pieces in. That's it. That's all it does. It's very simple, easy to use, and it makes these components much cheaper. In the case of the brush, you just need to make sure the shape of the metal that's holding the bristles is a certain shape and that it's a magnetic metal. That's it. Once that's designed properly, you can make those relatively cheap. You don't have to source the wood or make that connection or crimp it. You only have to put the brush in it, which would be a nice way. Plus, when you need to replace them, you can buy a single individual little head to replace it, or you could have multiple handles. One of the reasons they use cheap wood handles in makeup is, well, not necessarily cheap, but one of the reasons they use wood handles is because you have one per brush. You don't want that to be a large portion of the cost. It doesn't actually do anything. But if you have one handle for all of those brush heads, you can go ahead and make it really nice. You can make it like this. You can make it all ergonomic, or, it's obviously like a paintbrush, right? So make one that's really comfortable for painters, right? You can spend more money on this component because you're not making 20 of them or whatever it is. So that's the idea. That's one idea we're working on. And then I am going to go back to the 3D printed fishing lure as well at some point. The one thing I realized with a lot of these projects right now is, although I love printing fast, this only took, where is it? This one only took 45 minutes on the 0.8 nozzle. It takes a lot longer on the 0.6, but I think I gotta go down because in order to work on parts like this, I really, really need a fine resolution, and I just don't simply have it with the Volcano. I mean, the Volcano is designed to print large and fast, and this doesn't do that very well. So I didn't talk very much about this modular design, and this is just one version, but one thing you can do with 3D printing you can't do with injection molding is each one of these pieces has sections that are filled with plastic, but you can control the density inside each section. You can make it hollow, you can make a lattice work. In other words, you can control the buoyancy of each individual section independently. You can even put, as you're printing, you can even stop and put a couple ball bearings in each section to help make them sink and make noise. You can make individual sections that are made of various different types of plastics, such as metal infused plastics that would be heavier. So you could have essentially a weighted head. You could use glow in the dark plastics, which is another cool thing you can do. The possibilities are quite endless. And one of the things I have to work on and test is I don't actually want these joints to be too strong. I know that sounds weird, but the reality is one of the problems with fishing lures is they're very expensive. Swim baits can be $20 a piece. So the idea here is that if there's enough pressure in a certain direction, this happens, where you have the back end and this section simply slides off. In other words, if let's say you had a hook attached to this and you got onto a log, if you had enough strength in your line, now you probably don't considering how much force this takes, you could pull the rest of this lure free and only lose a single component. This is made out of PLA, which is a biodegradable plastic, unlike most injection molded fishing lures, which are made of ABS, which is a toxic plastic, and it lasts practically forever. So this would be a much more responsible solution to fishing lures in the future. Um, and I'm kind of interested to see how this goes. The other thing that I really like about this setup is it uses something that is fairly standard in size. This what do you call it? Wire tie is perfectly designed for its purpose, which is to act just like a muscle and backbone. It's very flexible in this direction, but not very flexible going perpendicular to it, which is perfect for what we're trying to do, because the perpendicular motion is what keeps it from sliding up and down and coming off. So it only, and the force, if I try to pull these straight back, I'm not going to be able to break that easily, even with the thin plastic that I have here. And that is something that needs to be adjusted. This is one of those situations where your printer setting is going to make all the difference, and it's going to change everything about the way these work. The cool thing is if you make them different colors, you can alternate them. I can make a very wire ties when it's scaled. Where is it? See if I can grab one of these. Little mini, yeah. So there's these very, very, very small wire ties, but in order to print like a version of this that's that small, and let's say, what is it? Let's see, is it half? That would be too convenient, wouldn't it? Looks like 60% of the width. So if I reduce this by 40%, I get a much smaller lure, but still get the same functionality. And that would be a really, really useful thing as well. So that's another project, but that's quite a long, drawn-out project that's going to need a lot of work. Even though they're small components and they take almost no time to print, this is going to require a lot of design work, a lot of testing, probably some help from various different people as well, but certainly something that we'll look at in the future. So that's where I'm standing this week. I am going to go back to this. I'll probably end up having some handle design printed, hopefully by next week, so I can start testing it, making sure it can actually fit on top of a pole or wood stick. I want it to work for both the PVC pipe as a standard, but also to work for any stick you get in the wild, so you can use it for the same functionality. A couple things we talked about was using it for a stand for GoPro cameras. People who do outdoor sports like ATV riding, biking, that kind of thing. You can set up a series of these with very colorful poles so you know where they are. Just stick them in the ground anywhere you want, and you can have an elevated position that can be adjusted any way you want, to allow for a very, very cool video to be made. So that would be a neat thing. And it would just, obviously you'd have multifunctionality, right? You could just hold it as your, what do you call it? As your GoPro camera stand, if you will. There's probably other ways we can make use of it, which is why I want to come up with something very, very standard for both ends. This curved side, which I did with this last design, is out. I'm not doing that. I'm doing something completely different to make it something that if I make this component out of wood, I can easily create that geometry. So what I did was I created a V-shaped insert instead. So all flat edges, no curved edges in that connection, and I think that's just going to end up being a lot easier to create these components for. So hopefully we'll get that design up and running here in the near future so we can actually test it. That would be cool. Alright, so long rant today, but I haven't talked in a while. So we'll see, we have one version. This is version 3, we skipped a couple. This was version 4, and this is version 5, or this is version 4, 5, and this is version 6. And I'm very, very happy with this design. This is I'll probably post for these types of bands, but those who love flat bands, I'm going to come up with a spin shooter that's designed for them. I realized that the style of hole is not going to work. I think what I was thinking is having 15 millimeter bands, which should fit nicely, and they'll come through, and then I'll have some form of peg, and then it'll go back in, and the peg will actually slot into a slot you can push in so that it will lock, and so when you pull it tight, it'll stay tight. I think that's what I'm going to end up doing, but I'm not 100% sure. I'm kind of wondering if you guys can help figure out what might be best for that. I don't have, obviously there's limited real estate on these kinds of things, and the one thing about the flat bands is I can't make this really pretty symmetric design. It's going to have to be two sides that are clearly going to be forks, and then one side is going to have to be your handle component hole. I'm sorry, your wrist brace hole. That there's no way I'm going to be able to make it symmetrical. There's just not enough space in this area. So we'll have to see how that goes. That's an easy fix, and probably I can get that design up real soon. Maybe by the end of this week. We'll have to see. Anyway, so have a good week, and hopefully see you later. Turn this thing off.